Okay, we need to get going here. Welcome. I think everybody's here, and I don't know if you guys can look around and find the one person you don't know. There she is. So Jennifer, you're going to get to know all the other people eventually. We get pretty close and a lot of help with each other, and it's really useful. I'm taping this because we have 3 students who are doing this remotely, and I'm using this mic because I didn't want to stand around with the headphone mic, and so and this one I'm not tied to the machine. With the other one, I could see myself walking off and tripping. So for the beginning of the class, I want to talk about the 2 sections of the class that I'm going to be leading you through. I refuse to think I'm the teacher for this one because I'm kind of maybe a day ahead of you. And then Joe is going to talk about the section that he's going to take you through. He is kind of the local LiDAR expert, and I think we're really lucky to have him. So I'm going to start with the syllabus. And the syllabus is actually under revision because I went through a couple of the lessons last night, and you guys are going to whip through those things. So the content hasn't changed, but I'm still working on the timeline a little bit. So don't get too bogged down in that. Let's see. We have a whole list of skills that hopefully you'll be able to address at the end of this course. The first 3 weeks are going to be partial review. In fact, the first couple days I think are going to be a review up until maybe the middle of next week. Anybody who did hillshade analysis or created a hillshade, you're pretty far ahead on this. So today and tomorrow and next week, we're going to be working through some Esri tutorials, and you're going to be using the My Virtual Campus, and I've sent you all, except Brenda, the access codes through Moodle messaging. So that'll be your first task, is try to figure out Moodle. You blocked me. I'm not allowed to send you things. So I'm trying not. Yeah, I'm trying not to take it personally, but we'll work that out. So.
I did not do that.
Anyway, I'm blocked from sending you stuff. So we will, after Joseph leaves us, we'll go through how to access that. I have new software for you. If you're remote, I will send you the access code, and you can download the software over the internet. It took me 3.5 hours to download, install. And just a caveat, when you guys install this, you want to go to Service Pack 5 and download that and update, because that'll fix some issues we've had last term. So the first Esri lesson should take you about an hour and 20 minutes according to Esri, and I think that's about how long it took. And it's really, what's the difference between vector and raster and, pixel size. It's pretty basic. And then it starts taking off from there and gets a little bit into remote sensing. And then we'll start with some looking at using spatial analyst, and some of that is contour lines, viewshed, slope, but then we get into map algebra and looking at distance comparisons and that kind of stuff. So the lessons are very detailed. The data's all there. They all work. If you get stuck, often there's a button that says show me what you did, and you can see what they did. So you'll be really successful. I think the challenge is to try to learn from them and not just finish them. And sometimes it's easy just to kind of click, click, click and get them done like Price, but you're not really understanding. So to help you with that, week 3, I'm going to give you a lesson that was developed by a woman named Ann Johnson from the National Science Geospatial Technology Center. And this was created in ARC 9.2, and it's really a module that looks at fire, slope, vegetation, and burn prediction, and slope failure prediction. But the fun thing will be that you have to figure out how to make the jump from 9.2 to 10. So there'll be some glitches that don't work, and that's what you guys would end up in the real world, is trying to problem solve some of those things. And then there'll be a 1-hour exam on Thursday. And Joseph and I just were talking about how to do the exam, and he came up with a scathingly brilliant idea. And we'll see how it goes. We're going to give you the exam as a take-home exam. So you'll be able to take it home, figure it out, and then you're going to come to class and actually take the exam. So you'll have an hour, hour and a half to do the exam, but you'll have the option of actually learning the stuff that's on the exam. So that'll be our first really rapid 3 weeks. I would say for most of you, 80% of that, 70% is going to be review. So it'll be a good opportunity to kind of get back in the swing of it. There's also some really great ways that Esri has you do things that I've never seen before. It's like, oh, wow, you know, we know that there's probably 8 ways to do anything in ArcMap. And so it shows you some other kind of cool methods. So now I'm going to let Joseph Gordon talk to you about his 3 weeks. And there you go.
Hi, I'm Joe, everybody. I recognize some of you from coming to speak to you last year, I believe. So I'm going to do kind of LiDAR analysis and some raster analysis as well. The LiDAR comes in a LAS format, which I think will be new to most all of you. But from the LAS format, we'll quickly kind of get towards the raster format. And since LiDAR is three-dimensional topographical data, it's a good medium, I think, to actually learn some of the basics of raster algebra, because you have to kind of think in a three-dimensional vertical way, and that's sort of how rasters work, is sort of layering on top of each other. So at the same time, we'll be learning really cool data, but we'll also be learning some fundamentals of raster algebra. So LiDAR, that's what it stands for. I had a few slides of just some visuals of kind of what we'll be working on a little bit. I think it's kind of in the order that we'll be working on, but it might shift around a little bit. So let's see if I can expand this. So this is just a very quick intro. You'll see this slide again, I'm sure, but this is what LiDAR is. It laser shoots out of the plane. Bad color scheme for anybody that's colorblind, but first, second, and third returns. I don't think you're supposed to use red and green. Yeah, this isn't my slide.
This is our colorblind guinea pig.
Okay, good. Yeah. This slide came from Dogami. I stole it. It's the Oregon Department of Geology and something. But at any rate, the kind of thick band coming right out of the plane hits the top of the tree. That's the first return. A little bit of the laser gets reflected back to the plane, but then a little bit more of the laser continues down into the middle of the tree, and that's the second return, and like hits a branch in the middle of the tree. And then that gets reflected back, and then maybe just a little bit more of the laser makes it all the way to the ground, and you get a ground return. You can kind of see on the left the point cloud. That's sort of what it looks like in three-dimensional space, as you get points kind of hit through the tree and some points below the tree on the ground. And so it's nice, you can get vegetation modeling, but you can also get bare earth modeling beneath vegetation, so you kind of get the best of both. Here's some quote-unquote cool examples of LiDAR. We have a highest hit on the bottom left there of Beaverton, and that's essentially that first hit that hits like the top of the tree or the top of a building, and it essentially shows you a 3D model of whatever's the highest point on the surface. From the side view, you can see the Portland State Office Building. That's what it looks like in a point cloud. And then the example of getting the bare earth beneath the vegetation, when you're just looking at the vegetation, you can't really see that there's all this landslide that's happened in the past, but when you look at the bare earth, you can see that beneath it. So that's the examples. One of the reasons people got excited about LiDAR when it first started coming out, or becoming more available about a decade ago, was that the USGS DEM 10 meter was sort of the best thing available at that point. And LiDAR, the 1 meter DEM, you can see the difference in detail. And so everybody was pretty excited, and it's starting to get even better than that, depending on the resolution of the LiDAR. So for our class, I think we'll start with Mount St. Helens. We'll do before the explosion and after 1980, which is kind of an obvious massive change, but then we'll also look at 2002 and 2004 data to see how it's changed since then. And because it's always got little surface changes occurring. There's not really any vegetation of interest in this area, so this is primarily going to be a surface analysis exercise. I think that'll be my first week will be introduction, and then we'll get into Mount St. Helens on the second class of that week, and that might bleed over into the second week as well. And then we'll get to vegetation analysis, and I think we're going to do the Sandy River, Oregon. I'm talking with a guy at the USGS right now about a couple of other options, but this one I've already got the data for, and it's an interesting area. I like this area because it's got obviously a river, some riparian area along the river, which is interesting to study. It's got little sandbars. It's got a little bit of built structure and some farmland. It's got a road. It's got power lines running down on the bottom. So it's got kind of a little bit of all sorts of stuff to look at in the three-dimensional structure. So going forth with that, the following slides are not of Sandy River, but they'll be examples of the stuff we'll be working on. This is an example of some vegetation extraction that I did in Eugene. It's probably not the best color to use green. It doesn't pop out as much, but you can kind of see that all that green bubbling is the trees being pulled out separately from the buildings. And we'll do some of that. And that's one reason I like this is because we'll actually have some buildings and other built infrastructure that we'll have to kind of deal with to not include that in the extraction. We'll also look at canopy height and density metrics of the vegetation, and this is, up to this point, all of this is going to be Esri based, ArcGIS, pretty straightforward stuff. Imagery from intensity values, and it's essentially a near infrared image, sort of, and it ends up looking like a black and white image of what's on the ground, and the laser, when it hits something, it has a light reflectance value, and that's called the intensity value, and so we'll make images out of that. And it's nice when you're doing analysis, sometimes people use imagery from other years or other sources. Some people like to try and use the intensity because you know it's from the same flight, same time that you're also using your LiDAR from. Lynn will do a little bit of contour stuff, but with the LiDAR on the left, you can see the data is so detailed and sometimes so noisy. There's a little bit of vertical error involved with the LiDAR that you get really noisy contour lines. And cartographically, it's not, sometimes people want it to be a little simplified from that just to get the general idea of what's occurring. So we'll talk about sort of post-process contour simplification. And then we'll also talk about pre-process surface simplification. Those are kind of two approaches. You do it beforehand on the surface itself, or you do it after the fact. And this is a slope image on the left, and you can see how noisy that LiDAR data is. You can picture just the points on the ground just constantly, there's a little bit of jitter that occurs. And on the right, you have essentially a thinning of the point cloud and a simplification. And in the process, you're able to do some edge detection. You can kind of see the roads pop out. And it works for buildings as well. And then after, that's all Esri stuff. After that, I'm going to throw you into some Fusion. And starting from the first class of week 3, I'm going to have you work on Fusion tutorials. They're pretty simple. There's about, I think, 10 or 12 of them. I think I went through them in maybe 10 or 12 hours, maybe an hour a piece, something like that. And so by the time we hit, I think, the end of week 2, hopefully you'll have gotten through most of those. And that essentially will be, I think, the bulk of your homework is doing those, so that when we get to the end of week 2, we can start using Fusion. And it's a free open source software package that I think is useful for anybody to learn that wants to work with LiDAR, and it's developed by the Forest Service. And this little sample on the bottom, it has a graphical user interface, which is fun to visualize the point cloud and look at three-dimensional structures. But the most important utility of it is in the command line, executable. There's tons of density metrics and forest metrics and vegetation metrics that you can do. And this is an example on the bottom of what that command line coding kind of looks like. And it's It looks a little scary at first, but it's for someone that has any kind of background in programming, it's very simple. But even if you don't, it's very simple. Essentially, you have a command cloud metrics at the beginning, you have a couple of switches, ID and new, and then you have an input file, the LDA file, and you have an output file, the CSV file. And these are all referencing prepackaged executable files that'll be on your drive. So it's very simple stuff, and it's very powerful stuff because you don't have to use a software package. You don't have to use a graphical software package that sort of eats up a lot of RAM. You can just run it straight into the computer and chunk through tons of data. And in the process of that, we'll also learn batch files, which is another good thing to know just in general, which essentially is how to run multiple commands in sort of a big job. It's essentially command line model builder. I don't know if you guys have used model builder at all, but it's essentially kind of building a long process in the command line. And so those are, I think, good tools to just know in general. And that's an example of point cloud in Fusion. So, I mean, it's nice because you can't really do this in ArcGIS. In Fusion, you can kind of zoom around and zoom in and look at the point cloud. And then if time allows, if we have an extra class at the end, I'm not sure that it will, it would be nice to apply some of what we've learned to an urban area. And that's an example of vegetation extraction in Eugene. And you can see it's not perfect, like on the bridge there, a little bit of the sign gets pulled out on the freeway. And so, I mean, essentially the sign topographically looks like complex vegetation. And so we'll kind of learn how, which I think is kind of a good segue to what Lynn will be teaching you next, which would be some image classification that could possibly clean up some of that noise that would occur. And that's about it. And then I'll give you a test. Pretty easy test, I think. So. And then, yeah, my background is I'm an MS student at the U of O. I've done a LiDAR research internship and private contracting for the Lane Council of Governments. I'm currently a research assistant on a climate change project at the U of O. And I've done a little bit of work for Infographics Lab at U of O doing GIS, and the Institute for a Sustainable Environment doing GIS. So I have a fair amount of experience, and I'll lead you through this. So that's my spiel.
That's a good spiel.
All right.
Good images.
Yeah.
Yeah.
May I ask this?
Yeah.
Loaded from Moodle?
This slideshow? It can be, yeah.
Okay.
Sounds good.
I'll do it. I'll put it on.
Yeah.
Stephanie asked if we would put that on Moodle. I know you guys could hear, but yeah.
Oh.
So
Yeah, hopefully I was loud enough
I
for
think
the
you were
mic.
great. We'll
Okay.
find out here. This will be on YouTube later, you know? We'll see how many,
Oh,
if we like go
cool.
viral or something. Wouldn't that be awesome?
Great.
Okay, and then the last 3 weeks, and so this gets a little flexible. If you guys are way into the LiDAR and we want to go a little longer, that's all doable. We'll just kind of,
Oh, can I say one more thing?
yes, sir, you may.
So the first 3 weeks were really canned Esri tutorials, and the next 3 weeks are going to be, at first, some canned Esri tutorials, but once we hit the Fusion, it's going to be more of a hodgepodge that I kind of create. And so there may be some fun learning as we go, but I have confidence that we'll all be able to get through it. But I foresee that there'll be some hands raising and why is this not working, and me running around and making sure it works right. So
A true teaching experience.
that'll
I
be
love
good.
it.
Yeah.
I love it.
I'm not afraid.
So, so then the goal is to move us the last 3 or 4 weeks of class into a different software called Envy. We have Envy on the lab, and I will get you the information if you want to purchase a 1-year student license of Envy. I think it was $150, I think. Don't quote me on that. I have to call and check that out with them. And this will take you through gathering Landsat images, and you'll be able to kind of select the areas that you want to study, go on to the different generations of Landsat, download images, and be able to do analysis on those based on their spectral reflectance. And that kind of a little bit of what Joseph talked about. We'll do a little of that in this first week in Esri. in ArcMap, and there's some of the capabilities in Envy that you can do in ArcMap, and so you'll see some duplication there. So that's how it's going to work, and I think it's going to be, what the nice thing is, if you're bored in 3 weeks, it's going to switch up in another 3, so you're just going to hang in there. Any questions about the syllabus or how the plan for the week? All right, so I'm going to stop this, right? Done.